We talk a ton about a computer's brain, the CPU, or its memory, but what about its nervous system? You know, that invisible network that lets every single component talk to every other? Well, today we're exploring the unsung hero of your PC, the computer bus. Think of it as the data highway that makes everything you do possible.
I mean, really think about that for a second. You've got this lightning-fast processor, a massive pool of RAM, a powerhouse of a graphics card. All these super specialized parts. How do they coordinate? They can't just, shout into the void. There has to be some kind of structured way for them to swap billions of bits of information every single second.
And that's exactly where the bus comes in. The whole data highway analogy, it is perfect. It's the shared communication path, a set of actual physical wires and the rules of the road, the protocols, that acts as the main street and the freeway for all the information zipping around inside your machine.
But of course, not all highways are built the same. And for decades, the biggest debate in computer engineering was all about the fundamental design of this data highway. In this debate, it would completely reshape how our computers are built.
So this slide here shows the two competing philosophies. On the left, you've got the parallel bus. The logic was super simple. To move more data, just build a wider highway. More lanes means more cars, right? A 32-bit bus had 32 physical wires, sending 32 bits of data all at the same time. But over on the right, you have the serial bus, which, well, it honestly looks like a step backward at first. It uses way fewer wires to send bits one by one. The whole strategy isn't about more lanes, it's about having a ridiculously high speed limit.
So, why did the super-wide highway fail? The killer problem is something called timing skew. Imagine trying to get 32 people to cross a finish line at the exact same microsecond. It's basically impossible. At slower speeds, it was fine, close enough. But as speeds shot up, those tiny differences in wire length and electrical noise meant the bits would start arriving out of sync, and that corrupts the data. The wider the highway got, the worse the traffic coordination became.
And this is why Serial won. By sending all the data in a single, orderly line, you totally eliminate timing skew. There's no race between the bits. This lets you just crank up the frequency, the speed limit, to absolutely incredible levels. And the result? You actually move more data and more reliably than the wider parallel bus ever could. It's this perfect counterintuitive example of how fewer connections can lead to way higher performance.
Now, this whole shift from parallel to serial wasn't just some academic exercise. It was a critical solution to a huge, growing crisis in computing. The bus itself had become the bottleneck. The highway was now causing the traffic jam.
In the early days, everything was pretty simple. Every single component hooked up to the bus. The CPU, memory, everything had to talk at the exact same speed. It was all dictated by a single system clock. It was like a single-lane road where everybody was forced to drive at exactly 30 miles per hour, no exceptions.
But then, CPUs started getting exponentially faster. All of a sudden, you've got this brand new sports car, that's your CPU, stuck on that 30-mile-per-hour road. To talk to a slower component, the CPU literally had to slam on the brakes, enter what's called a wait state, and just sit there, totally starved for data. The performance of the entire system was being dragged down by its slowest part.
This situation kicked off a kind of generational race among engineers. Every time they managed to fix one bottleneck, a new one would pop up somewhere else. The entire history of the computer bus is really just a story of them constantly repaving the road to keep up with the ever-faster cars.
So let's just walk through this evolution real quick. In the first generation, the CPU itself was the bottleneck. It was playing traffic cop for every single data transfer. To fix that, the second generation introduced a dedicated bus controller. Now this freed up the CPU, which was great, but it created a new problem. The bus itself became the traffic jam. The solution? Well, that was the third generation, which took on a totally new network approach. Instead of one single shared road, key components got their own dedicated high-speed express lanes to communicate directly.
And that brings us right up to the computer you're probably using at this very moment. That entire history, from a simple shared road to a complex data network, is playing out inside your machine right now. The king of the modern internal highway is without a doubt PCI Express, or PCIe. It's a serial bus, and it uses that network approach we just talked about, creating direct point-to-point links between your fastest components. That slot your graphics card plugs into, that's a PCIe lane, a dedicated superhighway that makes sure it never gets starved for data.
And on the outside of your computer, well, you use its cousin every single day, the Universal Serial Bus, USB. It took that exact same reliable, high-speed serial concept and applied it to pretty much everything, from your mouse to your external hard drive. It's really the ultimate proof of how that serial design won the great engineering debate.
So, let's tie this all together. The simple data highway inside your PC actually has a pretty dramatic history. The key plot twist was that huge shift from wide, slow parallel roads to these narrow but incredibly fast serial lanes, all to solve that nasty timing skew problem. This whole evolution was just a frantic race to eliminate bottlenecks, making sure the highway could finally keep up with the sports cars. And the technologies we rely on every day, like PCIe and USB, are pretty much the finish line of that race. Which leaves us with a really fascinating question for the future, right? We've seen the bus evolve from this single shared path to a whole network of point-to-point links. As our demand for data continues to just explode, will this trend continue until the very idea of a central bus disappears, and it's replaced by a true network on a chip, where every component is its own intelligent node? The highway might just be dissolving into thin air.